Hi everyone, how are you doing at home? With the current restriction movement order that we have in place and extended until 14th of April until further notice at the moment, so we will need to resort into this online video. So we will start a new topic, which is chapter 3, Oxidation and Reduction. Well, oxidation and reduction is a very common occurrence. There are many reactions in our daily life is actually oxidation and reduction. Respiration, for example, in human and photosynthesis in plant are both oxidation reduction. And since you're very hungry, staying at home, going to the kitchen, and igniting the stove, combustion is actually an redox reaction. Well, if you need more examples on oxidation and reduction reactions, I advise you to actually look up on YouTube oxidation and reduction in daily life, and you will see a lot of video that can help you see example, I hope, and understand what is oxidation and reduction around you. Okay, in this chapter, we will have 4 main subtopics. These are big subtopics, which means there are a lot of smaller subtopics under this big subtopic. So 3.1, redox reaction. 3.2, rusting of iron. 3.3, reactivity series of metals and its application. 3.4, redox reaction in electrolytic cell and redox reaction in chemical cell. So how your battery produce electricity is a very common oxidation and reduction or simply redox reaction. Okay, so basically the electrolytic cell and chemical cell is already taught in Form 4, Chapter 6, Electrochemistry. So I will not reteach this topic. Rather, I will only connect what you already knew with oxidation and reduction. So in this video, I will actually focus on 3.1, redox reaction, and I will further explain to you the subtopic under 3.1 redox reaction. Well, here you go. So under 3.1 redox reaction, we will learn definition, oxidation number, and examples of redox reaction. Under definition of oxidation and reduction will be in terms of oxygen. That will be the first definition. In terms of loss or gain of hydrogen, that will be the second definition. And loss or gain of electron, that will be the third definition. And definition based on increase or decrease of oxidation number. That will be the fourth definition. In this video today, I will focus on the first 3 definitions of oxidation and reduction based on loss or gain of oxygen, hydrogen, and transfer of electron. Okay, under this subtopic also is oxidation number. Well, this is a rather new terminology for you, but there are 5 rules to determine the oxidation number of an element in a compound, and this oxidation number is actually very much related to the IUPAC nomenclature of a compound. For example, iron 3 oxide, so the 3 Roman referring to +3 oxidation number of iron, and I will teach that in my next video. Moving on to example of redox reaction. This is 4 main example, which mean change of Fe2 plus to Fe3 plus ion and vice versa. Displacement of metal from salt solution and displacement of halogen from its halide solution. And last but not least, transfer of electron at a distance by using U-tube. And I want to remind you that 3.1 redox reaction, all of this will be included in your Form 5 Semester 1 exams. But if we have any changes due to our current situation, you will be informed accordingly. Okay, so let's just start. Redox reaction. The word redox, RED, actually refer to reduction, and OX refer to oxidation. So redox reaction will mean reduction and oxidation reaction that occurs simultaneously. Well, if you have problem in the exam to actually spell simultaneously, you can also use simpler words like occurs at the same time. So you can say reduction and oxidation reaction occurs at the same time. Okay, so defining redox reaction in terms of 1. Loss or gain of oxygen, 2. Loss or gain of hydrogen, 3. Loss or gain of electron, and 4. Increase or decrease of oxidation number. So to simplify this for you, I will use plus sign for gain and minus sign for loss. And the definition will be in terms of oxygen, hydrogen, electron, and oxidation number. Combustion is a very common oxidation reduction, and fuel will react or combine with oxygen in order for the fuel to burn and produce fire and heat. So oxidation is always some substance combined with oxygen. So oxidation is gain of oxygen, or fuel combined with oxygen. So for example, in combustion, so oxidation, gain of oxygen. So if oxidation is gain of oxygen, reduction will be the exact opposite, which is loss of oxygen. Now, if oxidation is gain of oxygen, in terms of hydrogen and electron, it will be the exact opposite, where oxidation is the loss of hydrogen and loss of electron. Now, reduction is loss of oxygen. So in terms of hydrogen and electron, it will be the exact opposite. Reduction will be gain of hydrogen and gain of electron. Now, in terms of oxidation number, from the word reduction, reduce. So the oxidation number will decrease. So if reduction is decrease in oxidation number, oxidation will be the exact opposite, which is increase in oxidation number. Well, it will take some time for you to familiarize yourself with this concept, but I hope the example that I use for each definition in terms of oxygen, hydrogen, and electron will help you to understand this better. Moving on, definition 1, redox reaction based on loss or gain of oxygen. So I will use displacement of copper to oxide by carbon is an example to illustrate this definition. So copper to oxide at the beginning of the reaction with oxygen, and after the reaction, copper to oxide become copper and it have lost its oxygen. On the other hand, carbon at the beginning of the reaction without oxygen, and carbon become carbon dioxide at the end of the reaction by gaining oxygen. So we can see one substance here lose oxygen and another substance here gain oxygen. So we can say that copper to oxide loss oxygen, and carbon gain oxygen. Since copper to oxide lose oxygen, copper to oxide is said to undergo reduction. And since carbon gain oxygen, carbon is said to undergo oxidation. So copper to oxide lose oxygen, carbon gain oxygen. And since copper to oxide lose oxygen, it undergo reduction. And since carbon gain oxygen, carbon undergo oxidation. Since copper to oxide undergo reduction itself, and at the same time copper to oxide causes carbon to undergo oxidation, copper to oxide is said to act as oxidizing agent because it causes the other reactant, which is carbon, to undergo oxidation. So inversely, carbon itself undergo oxidation, but at the same time carbon causes the other reactant, which is copper to oxide, to undergo reduction. So carbon is said to act as reducing agent. Okay, so I will further explain to you the definition of oxidizing and reducing agent. So in this case, A react with B. So if substance A undergo oxidation, substance B undergo reduction, because oxidation and reduction occurs at the same time, and we call that a redox reaction. If A undergo oxidation, it will cause B to undergo reduction. So because A causes B to undergo reduction, so we call A reducing agent. And if B undergo reduction, and at the same time B causes A to undergo oxidation, so substance B is called oxidizing agent. So to simplify that, substance can be a reducing agent or oxidizing agent. Reducing agent undergo oxidation, oxidizing agent undergo reduction. And the other substance that react with reducing agent will be reduced. And the other substance that react with oxidizing agent will be oxidized. Okay, moving on to my second definition, which is redox reaction based on loss or gain of hydrogen. And the example that I will use is hydrogen sulfide reacts with chlorine. So hydrogen sulfide at the beginning of reaction becomes sulfur. So hydrogen sulfide loses its hydrogen. Chlorine become hydrogen chloride. So chlorine gain hydrogen to become hydrogen chloride. So you can say that hydrogen sulfide lose hydrogen, while chlorine gain hydrogen. So hydrogen sulfide lose hydrogen and so undergo oxidation. Chlorine gain hydrogen, so chlorine undergo reduction. So hydrogen sulfide lose hydrogen, while chlorine gain hydrogen. So hydrogen sulfide undergo oxidation, chlorine undergo reduction. And while hydrogen sulfide undergo oxidation, hydrogen sulfide crosses chlorine to undergo reduction. So hydrogen sulfide, in this case, acts as reducing agent. Chlorine itself undergo reduction, but causes the other reactant to undergo oxidation. So chlorine acts as oxidizing agent. Moving on, the third definition, redox reaction based on loss or gain of electron. And the example is copper 2 oxide react with magnesium. So when you have the chemical equation, you must first convert the chemical equation into ionic equation, and from ionic equation we will write half equation. So before I do that, I will first show you, or rather do some revision on how to write half equation, which we learned in chapter 6 electrochemistry when you are form 4. So we will do that. So first, in order to convert chemical equation into ionic equation, you first change the ionic compound into its respective ion, which is Cu2 plus and O2 minus, while solid and another solid doesn't change. Only the ionic compound like CuO and MgO can be changed into its respective ion. And O2 minus ion appear on both sides of the both sides of the equation, so you can cancel them off. Now, in order to write the ionic equation, you need to rewrite the equation of what is left after you cancel out ions that are present on both sides. So we will start with Cu2 plus here. React with what you have here, magnesium, Cu, and Mg2 plus. Okay, now that you have the ionic equation, you will need to write the half equation. And in order to write the half equation, I will remind you the 4 steps to write the half equation. Step 1, 2, 3, and 4. Where the first step is you write the reactant and product. And here the reactant is Cu2 plus and the product is Cu. And here the reactant is Mg and the product is Mg2 plus. So step 1 is done. Step 2, you need to balance atom. But in this case, Cu is 1 on both sides are balanced. The atoms are balanced on both sides of the equation. Third step is you need to add electron to balance the charge. And the last step will be balance charge. Next, in order to know which side do we add electron, is it on the reactant or in the product side, we need to think again in terms of atom and how an atom become ion. And in this case, we are interested in positive ion. In order for an atom to become positive ion, the atom must lose electron. Because if you lose electron, you have less negative charges, you become positive ion. And for the positive ion, to go back into becoming atom, now the ion have less electron. That's why it have positive charge. So in order for the positive charge to become neutral, it must receive or gain electron. That way, the positive ion will now have in same number of electron and proton. So it will become atom again. So we solved that problem already. Positive ion, in this case, to become neutral atom, in order to do that, that positive ion must gain electron. So you can write that, gain electron. So, but then now we have another problem. Where do we write the electron? If we lose the electron or we gain the electron, where do we write the electron? So to put that simply, when we lose electron or when we gain electron, where do we write the electron? So this table will help you that when we lose electron, the electron is no longer ours. We already give away the electron. So the electron must be written in the products. When we gain electron, the electron is ours. So we receive the electron. The electron now reside on the reactant side. So copper 2 plus ion become neutral atom Cu by gaining electron. And when you gain electron, the electron is written in the reactant. So plus electron. And when Mg, which is neutral, to become positive ion by losing electron. And when you lose electron, you actually write the electron in the product. So to put simply, plus electron. So balance atom and add electron is settled, but the charge is not balanced. So if this is 2 plus, this is also 2 negative. And if this Mg2 plus, this is also 2 minus. So now you have a balanced charge. So that is a revision on how to write half equation for an ionic equation. So going back to our previous slide, on the half equation, so we can write that Cu2 plus become Cu and Mg become Mg2 plus. So Cu2 plus becomes Cu by accepting gain electron, and Mg become Mg2 plus by donating electron or losing electron. So this one Cu2 plus gain electron, Mg lose electron. So gaining electron, Cu2 plus is said to undergo reduction, and Mg by losing electron is said to undergo oxidation. So we summarize what we have learned just now. Substance that undergo reduction and oxidation is copper Cu2 ion, or simply Cu2 plus ion. Substance that undergo oxidation, magnesium, or simply Mg. So oxidizing agent or substance that undergo reduction as cause. The other substance to undergo oxidation is copper-2 oxide, and substance that acts as reducing agent or undergo oxidation and cause the other substance to undergo reduction is magnesium. So that will be very clear in terms of loss or gain of electron. However, in order to do that, you need to familiarize yourself on how to write half equation. So since this one is gaining electron, so you can say this is half equation. Lose gain electron is reduction, so this is half equation of reduction, and this one is half equation of oxidation by losing electron. So I just want to summarize what we have learned in this video. So we learned the definition of redox, where RED refer to reduction and OX refer to oxidation that occurs at the same time or simultaneously. So we call it reduction and oxidation reaction occurs at the same time, redox. So this can be defined in terms of oxygen, hydrogen, electron, and oxidation number. Since oxidations is always some substance combined with oxygen, so oxidation is gain of oxygen, and reduction will be the exact opposite, which is loss of oxygen. So if oxidation, if loss of oxygen, so in terms of hydrogen and electron, it will be loss of hydrogen and loss of electron. And since reduction is loss of oxygen, so in terms of hydrogen and electron, reduction will be gain of hydrogen and gain of electron. And from the word reduce, reduction, reduce, for reduction will be decrease in oxidation number, and oxidation will be increase in oxidation number. And for my next video, I will talk about oxidation number. There are 5 rules to determine oxidation number and how to determine the oxidation number of an element in a compound. Thank you very much for watching this video, and I hope this will help you during our restriction movement order. And please like and subscribe to my channel. And I just once again would like to remind you to stay home, because staying home can save lives. Thank you.